All right, and if you joined a little bit late, this is the last time I'm going to tell you. Once this week, you will get a random participation grade by joining and participating in the Paradeck link. So that is like 3 points if you just join and do it. So please make sure you are joining and participating. Right now, we have 24 people in the Paradeck, and we have 25 people in the Zoom call, so not bad. If you do have issues with Paradeck, please let me know in the chat so we can troubleshoot, or you can just put your answers in there. Okay, 5 more seconds for today's warm up, and then we're gonna do a part 2 in a moment. 3, 2, and 1. So when I lock your screens, come on over to the Zoom screen share so you can see your classmates' responses. And as you can see, we don't have unanimous voting here, but that is okay. The majority of us seem to be in the correct space. The bond between one metal and one non-metal is the type we're starting the details for today. It is ionic. Covalent is going to be 2 or more non-metals, and only metals is going to be metallic bonding. Okay, so hopefully you have a pretty solid understanding of those. We've been studying this part of it pretty much exclusively, but now we're going to start looking at the electrons as well. If you are struggling with these vocab words, use the Quizlet. That does not go away when we're not assigning it. You can always log in and access it whenever you need to. George noticed in the chat that I had these in order. That was a complete coincidence because I copied and pasted, because the next slide, very similar, but different definitions. Match the description in terms of electrons to their correct bond type. We have for the green one, the sharing of electrons. Oh, your screens are unlocked. We have blue, the number 5, sea of mobile electrons, or purple, number 6, the transfer of electrons. Which type of bond matches what is going on with the electrons? See if you can remember the little tricks I told you by looking at the bond name to help you remember which is which. One of these looks like exclusively one color with like a spattering of a few mistaken answers. The other 2 look a little tie-dye-y right now. So let's think about it. 5, 4, 3, 2, and 1. So if we look over here at my shared screen, you can see the overall answers for your classmates. Most people seem to think that ionic, I did just lock them right now, and we'll come back and I'll open them in a second. Most people are agreeing that blue, number 4, the sharing electrons, is covalent. Number 5, most people are agreeing that the sea of mobile electrons is metallic. And number 6, it looks like most people are agreeing that ionic bonding is the transfer of electrons, okay? But most of us seem to be in agreement that these are our correct answers. Ionic bonding is going to be when you have a transfer of electrons. I remember that with the root word ion, meaning an atom that has either gained or lost. And so ionic, you have one of each. Covalent bond, sharing electrons, the prefix co, work together. They work and share their electrons. And then metallic, we've spent a little bit more time with these. I'm happy to see most of us remembered that one, is going to be the sea of mobile electrons. Okay. If you are still struggling with the different types of bonds and their little descriptors, I will repost the link to the Quizlet today so you can study a little bit more on your own time, because it is very important that you know what's going on with which type of bond, because as we start naming and drawing and writing formulas, the rules are going to be a little bit different for each of the different types of bonds. Okay, and so today we're going to start going over in detail with ionic bonding. By the end of your asynchronous portion today, meaning including what you do in the Edpuzzle assignment later today, I want you to be able to say, I can find the chemical formula for binary ionic compounds using the crisscross trick. You will learn more about the crisscross trick explicitly in your Edpuzzle, but binary ionic compounds are going to be ionic compounds between 2 elements, and chemical formulas are going to be those abbreviations that tell you how many of each atom you have in a compound. For example, water's chemical formula is H2O, which is 2 hydrogens bonded to 1 oxygen. Carbon dioxide's chemical formula is CO2, which is one carbon bonded to two oxygen atoms. And something like glucose, C6H12O6, means six carbon atoms bonded to 12 hydrogen atoms bonded to six oxygen atoms. Okay, and so those are going to be chemical formulas, which we're going to start looking at today. But first, we got to know exactly what an ionic bond is. Okay, we do know that it's between a metal and a nonmetal, and we do know that it is a transfer of electrons. But why does this happen? You have a transfer of electrons when you have two atoms in which one of them is relatively strong. Okay, it is so strong that it is able to steal an electron away. And that strength is going to be measured by looking at something called electronegativity. You have defined this word, assuming you did lab number 5, and it's also one of the ones that's on table S on the back of your periodic table. And so we'll start using this one a lot more in this unit because you're going to be comparing the electronegativity between two atoms to see what's going on. Okay? Electronegativity is defined as how strongly an atom wants to gain an electron. And as you guys should know, there are some elements that really want to gain electrons. For example, somebody like fluorine, starting with 7 valence, really wants one more. Fluorine has the highest electronegativity of any element on the periodic table. Whereas somebody like sodium with 1 valence electron wants to lose it, is going to have a much lower electronegativity because they don't want to gain, they want to lose. Okay? And when this happens, when one atom steals an electron from the other, you're going to create two ions. The one who's stealing is going to become negative. The one who lost their electron is going to become positive, and that's going to hold them together. Because as we learned in lab number 2 or 3, positives and negatives attract. Okay, and so this is going to happen between a metal and a nonmetal because metals always want to form positive ions called cations, in which they lose electrons. They're going to give them to nonmetals who really want to form negative ions by gaining those electrons. Okay, and so the example we went over when we first talked about the different types of bonds was sodium chloride. This one's going to be talked about in a lot more detail in the video we watch here in a moment. But the reason why sodium and chlorine work so well together is that they have what each other wants. Sodium wants to lose an electron, chlorine wants to gain. So chlorine has an open spot to take that electron from sodium, and everybody becomes happy. Okay, and so this picture at the bottom, this is your final Lewis structure. And if you notice, it's just the ion for sodium drawn next to the ion for chlorine. And there's really nothing more to it other than drawing those ions next to each other. That's why we spent quite a bit of time last week reviewing how to draw these ionic diagrams, so that way we can draw them for compounds moving forward. Okay, here's a little funny for today. Chlorine saying, you complete me, because sodium gives chlorine that one more electron it wants to be happy. How cute. Okay, so we're going to watch a video. So leave your Pear Deck open, but please come on over to the Zoom screen share where we're going to watch it together. Please let me know this volume situation, if it's good or bad in the chat, and we're going to go from there. One of these, it's going to ask us to pause and you're going to try it on your own. You can put your brainstorming in the chat if you want, or you can write it down or just think it in your brain. Okay, so let's see what we got about ionic compounds.
We have previously learned about the formation of ions. Now we will learn about ionic bonds.
Ions, as you already know, are formed from the loss or gain of electrons. Electrons, however, do not suddenly appear or disappear. They are, in fact, transferred from one atom to another. Let's look at sodium chloride as an example. Sodium loses one electron to form a sodium ion. The electron is not lost, but transferred to chlorine to form a chloride ion. So we have a sodium ion and a chloride ion. They are oppositely charged ions and will be electrostatically attracted to one another, much like how opposite poles of a magnet are attracted to one another. This electrostatic attraction is an ionic bond. Sodium chloride is an ionic compound because it is held intact by ionic bonds. The same thing happens with magnesium and oxygen. Why don't you grab a piece of paper and a pencil and draw the resulting ionic compound, magnesium oxide? Please pause.
All right, so I want you guys to think about this one. Just think about it in your brain, write it down, or type it in the chat. What do you think is going to happen between magnesium and oxygen when they form bonds? Magnesium starts out with an electron configuration of 282, as you can see here, and oxygen starts out with an electron configuration of 2,6. Okay, so just take a moment to think about it, and we'll go over it in a moment. Okay, a few more seconds and then we'll let the video reveal to us what's going to happen. And what we're looking at here is we're looking closely what's going to happen with the electrons. We have magnesium, a metal with 2 valence electrons, and oxygen, a nonmetal with 6 valence electrons. All right, so let's let the fuse school lady tell us what's going to happen.
Magnesium oxide. Please pause the lesson and resume when you are done.
We already did that.
Magnesium transfers its 2 valence electrons to oxygen, forming the magnesium ion and an oxide ion. The resulting ions are electrostatically attracted to one another, forming an ionic bond. Did you get this right? Did you remember to include the charges on the ion? Now, let's look at calcium and chlorine. Calcium loses 2 electrons to form a calcium ion. One of these electrons is transferred to a chlorine atom, and another is transferred to another chlorine atom, forming 2 chloride ions. The calcium ion is electrostatically attracted to the 2 chloride ions because the opposite charges must fully balance each other out. In all 3 examples, the resulting ionic compounds have an overall neutral charge because all charges are fully balanced out. In summary, an ionic bond is defined as the electrostatic attraction between oppositely charged ions. When an ionic compound is formed, the charges must be balanced so that the resulting ionic compound has an overall neutral charge.
Alrighty, so we are going to do a little thinking question. You went through the magnesium one. Now I want you guys to think about what's going to go on with calcium and chlorine. She went through it kind of quickly, but the formula for the compound that forms between calcium and chlorine is CaCl2, meaning 1 calcium bonded to 2 chlorine ions. Okay, and so the question is, why does calcium need to work with 2 chlorine atoms to form the compound calcium chloride? Okay, so please go ahead and type your answer in the Pear Deck. You can type it directly in there. If you're having issues with the Pear Deck, you can type your answer in the chat. Okay, it's locked. Thank you, John. Here we go. Since it's locked, I'm going to go through one more thing here for magnesium oxygen. Magnesium here, though the example that went through the video, magnesium wants to lose 2 electrons. Luckily, oxygen has exactly that many empty spaces for everybody to react and be happy. Okay, magnesium is going to form a positive 2 ion, oxygen is going to form a negative 2 ion, and they're going to attract to each other, and that attraction is your ionic bond. Okay, so now magnesium and oxygen, you needed 1 of each. Sodium and chlorine, you needed 1 of each. But now calcium needs 2 chlorines to be happy. So why is this the case? You can type your answers in the Pear Deck. Thank you, John, for letting me know it was locked. It should be good to go now. I'm seeing some good answers here. I'm seeing some very detailed answers, which is good. If you're ever stuck, always go back to the octet rule. Okay, that's kind of like our guiding force in bonding. And so if you ever don't really know what to do, think about the octet rule. All right, I'm going to read through some of your answers. I will also screen share them. So if you want to look at the Zoom screen share, you can read along with me. I have this one looks good because calcium wants to lose. Sorry, hang on. Each chlorine is only missing one electron, and in order to fulfill the octet rule, you need two chlorine atoms. That is good. Since chlorine has 7 valence electrons and calcium has 2 valence electrons, it needs to give each chlorine atom one electron. Okay. Similarly, I think calcium needs 2 chlorines because chlorine needs 1 electron to be full, but calcium has 2 to get rid of, so they need to find another one. That's kind of how I like to explain it. So good, we're on the same page. Okay. But ultimately, you guys are on the right track. In the chat, I got 2 responses that look good. I think calcium has to work with 2 chlorine atoms to form a compound because it is one part of the process in helping everybody fulfill the octet rule. There needs to be 2 atoms of chlorine because calcium has 2 valence electrons, not 1, and another chlorine atom needed to remove the other electron. Okay, and that is exactly right. And so sometimes it's going to be pretty clear just by looking at like these images what's going to happen with your atoms. Okay, moving forward, you're going to know calcium chloride is going to form between 1 calcium and 2 chlorines. And you're going to know that by learning some like shortcuts. But if you look at it in what's actually going on, you guys got it. Calcium needs to get rid of 2 electrons, but chlorine only has room for 1. And so you find 2 chlorines, then everybody is happy. Okay? We are going to start learning how to name these compounds, how to write the formulas, how to draw them. And it's going to always come back to the valence electrons and the octet rule. Okay. And so you guys are going to do a quick video today on Edpuzzle. It should have just posted on Google Classroom. It's called 12.14 Prep Work. This is going to be new information. Okay. We're going to be looking at compounds and trying to write their formula by using what is called the crisscross rule. They'll explain it in the video. And then also how to name these compounds. You've heard me throw out chemical names like dihydrogen monoxide, sodium chloride, calcium triphosphoride, or whatever. And we're going to start to learn how to name those things today. Okay, ionic bonding has one set of rules, it's easier, and covalent bonding has a little bit of different rules. And so we're going to go one at a time. So if you go on over to Google Classroom, it should presumably say stream was updated, and you will see today's assignment, which is an Edpuzzle that you should complete before school starts tomorrow. So that way you are prepared for tomorrow's lesson. We're going to go through the details of naming ionic compounds. Okay. A video of this lesson will be posted. It is recording right now. It'll be posted within the hour, hopefully. Your slides will be updated as soon as this class is over. But if you have any questions, feel free to shoot us an email. But otherwise, I hope you have a great Monday. It is the start to the last full school week of 2020. Next week's only a half week, so let's make this a good, long, productive week, all right? Otherwise, have a great day, my friends, and I'll see you tomorrow.
Thank
Work
you.
on your
Have
ed
a good
puzzle.
day.
All
You
right,
too.
take care.
Bye.